All right, we're going to work with right triangle trigonometry in this video. So we've worked with the unit circle, and the radian measure of that central angle is equal to the intercepted arc. Thus, the value of the trigonometric function at that real number t is in the angle of t radians. So there's a figure below showing the angle pi over 3 on the unit circle. And then there's a point x comma y. In the second figure, here would be pi over 3 or 60 degrees. And what we do is we can drop a straight line down, creating a right triangle. And then this would be your x value and your y value of your ordered pair. And then this radius is always 1, like it is over here. So, right triangle trig definitions. Here's a right triangle, and you have your angle theta. Opposite that side is called opposite. Opposite the right angle is called the hypotenuse. And then the length of side adjacent is side B. So below are the 6 definitions of our trig functions with that acute angle theta. So the sine of the angle is opposite over hypotenuse. So that we remember it as so. And then cosine is adjacent over hypotenuse, which remember is ca. And then tangent is opposite over adjacent, which remember as TOA. So these are the big 3. The ones on the right are just the inverses. Hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. So notice these are our trig ratios in reference to side A, B, and C. So this is remembering the sine, cosine, and tangent. This is what we use at Park. Here is another way to remember it. Some old hog came around here and took our apples. So this is what I learned when I was in school, to remember the big 3 is SOHCAHTOA. So let's go ahead and do an example. Find the value of each of the 6 trig functions of this acute triangle. So we have our angle theta. You always want to identify the 3 sides. So let's start with side opposite. So that's length 1. Side hypotenuse is length 3. And then side adjacent, we don't know. So we need to find side adjacent. So we're going to use the Pythagorean Theorem. A squared plus b squared equals c squared. And remember that c is always your hypotenuse. Let's go ahead and sub in what we know. So we have 1 squared plus b squared, which is unknown, and then c squared. And we're going to solve for b. So we're going to square those numbers. 1 times 1 is 1. 3 times 3 is 9. Now we're going to subtract 1 from both sides. And we get 8. Now we need to undo that 8 with the b squared. So we're going to square root both sides and then simplify it. So I get square root of 4 and square root of 2. Well, the square root of 4 is a perfect square. Square root of 4 is 2. So this is your exact value. So I'm going to go ahead and put that over here in my triangle. Now I'm going to go ahead and do my 6 trig functions. So the sine is so opposite over hypotenuse. So we go up and find side opposite, which is 1, and the hypotenuse is 3. Cosine, ca, adjacent over hypotenuse. So adjacent is 2 square roots of 2, hypotenuse 3. Tangent, TOA, opposite over adjacent. The side opposite is 1, side adjacent is 2 square roots of 2. Well, this one we cannot leave as it is, we have to rationalize it. So we're going to multiply the numerator and the denominator by the square root of 2. So we get multiply across the square root of 2 divided by 2. And now that square root of 2 times the square root of 2 is 2. So our final answer is the square root of 2 over 4. So those are the 3 trig functions for the big 3. My suggestion is to just now use your inverses. So the inverse of the cosecant is the sine function. So we're going to reciprocate that 3 over 1 and then simplify it. The secant is your reciprocal for your cosine. So that would be 3 over 2 square roots of 2. We do need to rationalize it. And then multiply across. Square root of 2 times square root of 2 is 2. So our final answer then is 3 square roots of 2 over 4. The last one, the cotangent, is the reciprocal for the tangent. So I'm going to work with this one right here, and I'm going to reciprocate it. 2 square roots of 2 over 1, or 2 square roots of 2. In the black writing, you could have used these ratios too if you wanted to, instead of using the reciprocal identities.